Hello and welcome to Gus Codes. I am Gus, and in this session of xganso I will implement the ECS Entity Component System architecture using a TDD test-driven development approach. I decided to use ECS after the great results obtained when prototyping it in previous session. This component is central for the entire development of the game. Therefore, it is paramount that it is well implemented. At the end of the session, we aim at having a working implementation of ECS and a comprehensive set of tests that should validate the ECS implementation. To achieve this goal, I will use a TDD approach. In a nutshell, I write a test which should fail. When the test is red, we program ECS until the test passes. When the tests are green, we can refactor and improve the code. Finally, we move on to the next test and repeat the process. The test will be written based on the requirements and intended behavior of ECS. Let's start coding. Let's start with a little description of what ECS requirements are. I wrote some small requirement list. Let's put a title here, ECS Requirements. The word initial is empty and it is clear after a reset. Each created entity has a unique ID for identification. When an entity is deleted, all its data within the word is deleted. If there is no entity to delete, no changes should be done. Within the ECS framework, one can add as many components to an entity as possible. When adding an existing component, it should override the values and not create a duplicate component for the entity. One can also remove components from entities. The entity may still exist even if it has no components at the moment. If a component to be removed does not exist, no change should happen. One can also query for specific components of entities. When they do not exist, they should not crash but return a null value. It is allowed to add as many systems as wanted. The system should have an execute method that is called each frame. The system may only operate upon eligible entities according to a set of components that is not empty. In case of getting eligible entities that match an empty set of components, it should return an empty set of entities. For debug purpose, it should be possible to query all the components of an entity. If the entity does not exist, it simply returns a null value. So I think it's a good description of what we are aiming for, and we are using this test-driven development. First, we're going to set up unit tests for our project, and we're going to start cutting these requirements into test cases. I'm gonna copy these requirements into the test, and then it's gonna be easier to follow. Okay, so here we start defining some elements that we need to test. The idea of the TDD, just to remind, is that first we write the test, then we program until it passes. Once it passes, then we can refactor to improve the code, and then we move on to the next test. We are only allowed to program something if the test is read. We already have a first version of ECS, but I'm not going to use that. Okay, for the time being, I'm gonna make the word as a dictionary and the systems as a list. Okay, perfect. And the second one is Okay, now we have to implement the reset. Currently we are doing this, but we might have to change in the future. Okay, and with this I think we concluded this first part about the word. So when we create an entity, we should receive the ID back. So let's focus on the first case. Or let's already say it's unique. The test is not really correct because a list can have similar elements. So let's move these two. Okay, see now, because it's always returning 0. So this time I'm gonna take a copy from the previous implementation, which was quite nice. And now the question is, do we want to have a list of entities? And I think the answer is yes. Perfect. So now we can add here. Of course, here the reset. Okay, and we can move on. Each created entity has a unique ID for identification. Okay, this is set here. We can always put a super high value for that. I think 1000 is good. When an entity is deleted, all its data within the word is deleted. So we are using a dictionary of component entity and maybe we should start with that case, right? Okay, so here we deleted the following one, which does not exist, so it works. Unexpanded found. Okay, so now we have to handle what happens first. When an entity owes data, if there is no entity, no change should be done. With these three tests, I think we cover. Okay, let's move on to the components. One can add as many components to an entity as possible. Let's see some things here. I'm gonna use a default dictionary. Let's skip that for the time being. I just thought about a case that is should not be added, it is added, so I think this word is strange. I'm gonna copy that from the other one because I thought it was very nice. First of all, we need a... okay, just the type. Let's fix this actually because we know it's wrong. And also I would like the component to have a base class, so I'm gonna okay, so we managed to insert a string, an int, a float. Let's see, within one can add as many. That's true. When adding, it should override the values and not create a duplicate. Okay, we can try this one. some entities. True. Let's try this one. So for instance, here we remove the entity and sub13. Of course. Entities. If component does not, no change should happen. That's one can also query for specific components. Now let's do some refactoring here. Okay, now it's much better how we do everything. If a component does not they do not exist, return a new value. I think we're finished with the component. Now let's move on to the system. It's allowed to add as many systems, so let's system should have an execute method that is called we are using this magic mock to create some systems, and then we check that it was called once. Also, we can maybe do the opposite, test not execute system. So, and then here we should check call magic mock. That's very good. It is allowed. The system should have that's called. Okay, so we create the protocol. May only operate upon eligible entities according to a set of components. Okay. Ooh, now I understand why everything's a mess. Now I have to see how it's done, because that was very interesting done, this prototype. Okay, so it's a I might copy how it was done because it was a very interesting implementation. Or maybe let's do a simple one that we can understand and then we can expand. So basically, okay, and now let's do the debug. I'm gonna do this different now. Let's run everything once again. Everything is working. I think we cover all the requirements. Just to review, we use this test-driven development to think about the use case and then implement them. So it should have a very consistent implementation, only the necessary things. We can also compare with what we already have from the previous prototype. We added the entities here. We added a lot of methods to check if some components, some entities already there. For the add component, we check for the entity and the rest is the same. Get component, we do the checks beforehand, which is better, I guess, because here it could lead to some errors. We do a little bit more defensive programming. Get entities with, we use this list arg, and we also, instead of doing everything in one line, we separate and we do a little bit defensive programming as well. Add system and update. Go execute, and we have some other methods. So overall, I think it's a success. We managed to define exactly what we wanted and to do a very concise implementation. Now let's see what we have to check in. Yes, let's delete this one. Game design document. What did it change? Ah, this is the MD. The prototype ECS, because there was a mess. Yeah, let's move this ECS requirements, ECS and this. So session 6. And also the settings, because we changed a little bit here for this session, so it should work. Okay, cool. And commit and push. And here it is. Our changes are done. To summarize, today we implemented ECS using a TDD approach. Using this approach, we not only implemented ECS with a set of validating tests, but also kept the code concise and clean. The main advantages of TDD are forcing us to think about how to test our components, resulting in very testable components from the start and having tests native to the development, and not as an afterthought. With the current implementation of ECS, we laid a solid foundation to build the game systems of xganso. In the next session, we will start implementing the rendering system and display our 5 initial classes. Thank you for your time and see you in the next session.